Now let's see how we can implement queue using linked list, and we will write our program in Java. So when we are saying that I want to implement queue using linked list, there are two elements involved, queue and linked list. So using linked list, we want to create a data structure that abides by the rule of first in, first out. So in linked list, when we are adding data, so let's say when I add my first node, let's say 2, then I add 3, then I add 4. So if this linked list is behaving as a queue, then whenever we remove an element, then first element that was added should be the first element to be removed. So in this case, the very first element that was added was 2. So whenever we perform the dequeue operation, this 2 should get removed. So using linked list, we want to implement something like this. So how can we do that? So let's say we have to perform two operations, major two operations, enqueue and dequeue. So the enqueue inserts an element in the list and dequeue removes an element or removes a node from the list. So we have already talked about linked list several times. We'll just quickly see what happens in it. So in linked list, we have several nodes. So these are nodes. Each node has two fields, data and next. So this data is the data that you want to store, and this next is a variable that always points to the next node in the list. Now using these information, I have to create a linked list such that the enqueue operation always happens such that FIFO is implemented. Now what we will do is, how can we do that? So performing two operations, what I'll do is, let's say this is a list. In order to ensure that 2 is removed from the front, what we will do is we will always keep 2 as the first element. Okay. So now the question is, how will we add new elements? So whenever we have to add new element, we'll add it at the end of the list. So what I'm doing is, I am performing the enqueue operation at the end of the list, and I'm performing the dequeue operation at the front of the list. So what happens is that whenever an element has to removed, it will always remove from the front of the list. So this 2 was the first one to be inserted. So let's say while enqueue, this 2 is the first one to be inserted. So while dequeue, this will be removed first. Similarly, 3 was the second one to be inserted. 3 will be the second one to be removed. Hence, this FIFO will work when we are deleting element from the front and inserting at the end. Now the question is, how we are going to take care of this particular thing, that deletion happens always from the front and insertion from the end. So we will maintain two variables. One will be front and another will be rear. So always the enqueue will happen from the rear end and the dequeue will happen from front. So we will keep track of always that what is the last node in our list, and the next node, whenever a new insertion has to be done, should be inserted after that particular node. So this is my rear, let's say, and I have to insert 7. So 7 will always be inserted at the end. So now let's write down what are the different operations that we have to perform for enqueue. We have to insert element at the end, and for dequeue, remove from front. First, let's perform the enqueue operation and then we'll do the dequeue operation. Now let's say I have to create a queue in which first I'll insert 1, then 2, then 3, and then 4. So 4 enqueue operations that I have to perform. So initially my front and rear both will be null because I don't have any element in my queue. Now what I will do is, I'll create a new node. This node is created with data 1. I'll check that if rear is equivalent to null, which means that there is no data, or which means there is no element in the queue. So what I'll do is, I'll start to make my front as well as rear point to the first element. Now let's say I have to insert another element 2. So now what I have to do is, as I said, that we always insert new element after the rear. So in order to insert 2 here, I'll create a new node with value as 2, and next of rear will start pointing to 2. So now 2 is at the end, but we always have to ensure that rear points to the last element. So we update our rear to point to this particular element. Now we have to insert 3. We do the same thing. rear starts pointing to this. Now, what are the operations we have to perform every time we have to do the operation? We have to do the enqueue. So the very first thing we do is we create a new node. Then whatever data we pass here, we'll check that if rear is equivalent to null, which means there is no element in the list. In that case, what we will do is we'll make our rear as well as front point to new node. And if our rear is not null, what I'll do is rear dot next is equivalent to new node. So this ensures that the next of rear starts pointing to the new node. And now I also have to update my rear. So rear becomes rear dot next. So this is how we perform enqueue operation using linked list. Now the question is, how do we do the dequeue operation? So let's see that as well. So now the list that we have after we perform first set of operation is this: 1, 2, 3, 4. This is So the front points to the first node and rear points to the last node. Now we have to perform the dequeue operation. So in dequeue operation, always remember that we have to remove the node which was inserted first. So first node that was inserted is pointed by front. So we have to remove this particular node. So obviously before removing, we will check that if front is equivalent to null or not. So in that case, we will simply return, because obviously there is nothing in the queue, and how we will do the dequeue operation. So let's say there is something in the front. What we will do is we'll update our front to point to the next element of the list. So now front starts pointing to this particular element, and this is having no reference. No one is pointing to this particular element. Hence, this will be removed from memory eventually. So now we have front is equal to front dot next. But there is one thing to take care of. So let's say we have a list something like that. So in this case, if we do front equal to front dot next, so what will happen? Front will become null, okay? But our rear will still point to 2. So what we have to do is we have to check that if front, after this operation, if front is equivalent to null, we have to update our rear to front, which is null. So these are the operations that we have to perform. We simply have to update our front to point to the next element of the list, and we also have to check that if the next element is null, we make sure that we update rear as well. So the time complexity for both enqueue and dequeue is O of 1 using linked list. Now let's see the code for this. Now let's write code for implementing queue using linked list. So we have created two classes here. We have list queue and we have list main. List queue is where we will write the enqueue and dequeue operations, and list main is from where we will call these operations. In list queue, we will add our node class, which will have two elements, data and next. And we will also have a constructor that takes parameter as the data and initializes the data of that particular node to data that has been passed. So this is my node class. In list queue, I'll update my front and rear to null. Which means initially we do not have any node in the list. List is empty. Here we will write two operation void enqueue that accepts data as the parameter, and we have, let's say, int dequeue. So here we won't only just delete the element, we will also print the data of the node that was deleted. So let's say we have Now let's call first enqueue operation from our main list and see that how the enqueue operation will be performed. So in order to call methods from list queue, we first have to make object of list queue. and then we call q dot nq. We pass the data, let's say I pass 1, and then I again call it. I pass the data 2, and then I pass the data 3. Okay, so let's see how the NQ operations will be done. Let's say this particular call happens. So the very first thing we will do is we'll create a new node. Pass the parameter as data. So a new node gets created. We will check that if rear is equivalent to null. In that case, we have still our list as empty. So we'll update our front and rear both to start pointing to new node. And we will return. So what happens after this is that a new node with data 1 is created in the memory and inserted in the queue. Now let's say we again call enqueue2. So in that case, we have already data there. We have updated our front and both rear to point to that particular node. So what I'll do is rear dot next is equivalent to new node. So this ensures that new node is inserted after rear, and we obviously have to update our rear to point to the next node. So this ensures that new node is inserted after the rear, and this ensures that rear is updated. So after this NQ operation, let's perform DQ operation. So after these three call happens, we have a queue with data 1, 2 and 3. Now let's perform the DQ operation, and we will also print the data of the node which is removed from the queue. So in order to perform DQ, what we do is we first check that if front is equivalent to null, which means there is no element in the data, which means there is no element in the queue. Maybe I'll print the message that queue is empty. I'll return -1, or what I'll do is if the front is not null, we'll keep the data of front in a variable, and I'll update my front to point to the next element of the queue. Now as I said that we have to check that whether front is equivalent to null or not. So I'll do if front is equal to null, the updated front is equal to null, which means now there are no element left in the queue. So I'll update my rear to point to null, and after these operations I'll simply return the data. So now let's say after we do this and after we run this, so let's say after we have performed this particular operation, what is the value of data that we are getting? So as you can see, we are getting the data as 1, which means that 1 was the first element that was inserted, and hence it should be the element to be popped out during DQ operation, which has happened. Now let's call this particular thing again and see that if we are getting the output as 2. So yes, first 1 gets removed from the queue and then 2 gets removed. So this is how we can perform NQ and DQ operation in our code. So let's just quickly dry run this particular thing. So first let's run for queue. So initially we passed 1. So what will happen? A new node with data as 1 is created. We check if rear is equivalent to null, which is initially. So both rear and front starts pointing to this particular node. Now we again call NQ operation with value as 2. What will happen? We check if rear is equal to null, which is not the case. So rear dot next equal to new node. A new node 2 is created, which is inserted after this particular node, and my rear is updated to point to this particular node. Similarly, when we insert 3, then rear dot next equal to 3 ensures that 3 is inserted here, and then we update our rear to point to this particular element. Now let's say we call DQ operation. So in that case, we check if front is equivalent to null, which is not the case here. So what we do is we keep the value of front in our data, which is 1. We update our front to point to front dot next, so which is this particular element. So now front starts pointing to this. We check that if front is equivalent to null, make rear equal to also null, which is not in this case, hence we need not do this. But let's say if we have had just 3, both rear and front would point to this. And when front becomes null, we have to ensure that rear also becomes null. So the time complexity for both the operation is O of 1.